All right, this is the, I think, third time, maybe fourth time we've talked about transformations now, right? Okay. So this is the time the rules are going to change, right? No, they're the same rules for every sort of parent function that we deal with. So all I'm doing with you today is just reminding you of the rules. It's going to go fairly quickly because, like I said, we've already done it a couple times. Okay. So this is the window you're using on your calculator. This is the parent function of a square root function or a radical function. Okay, so specifically it is a square root function. In general it's called a radical function. Fair enough? Okay. Y equals the square root of x plus 3. Where is the end point? Okay, for the record, this was a problem because is it coming this way and stopping here? Then why is that called the end point? Because that's what it's called, right? We know it's the starting point. It's just called an end point. I think it's a misnomer, but they didn't ask me. Okay? But tell me, where's the end point of this function right here? 0, 3. So how does the function compare to the parent? Vertical shift up 3. Watch what I'm going to write. There are times when it is okay to be lazy when I know you already have the vocabulary. Is that the best plan? No. The best plan is for me to have you write vertical shift up 3. Okay? And on a test, what am I going to expect? Vertical shift up 3. Right? But I am very confident that you already know the language. If you want to go ahead and write vertical shift up 3, that's perfectly fine. Or you can model what I'm doing. Or you can do what I'm modeling. Sorry. Okay, either one, because I know you know the vocabulary. What about number 2? Oh, sorry, we didn't graph this one, did we? 1, 2, 3. What about number 2? What's the graph look like? It's moved down 3. So it looks kind of like that. So the end point then is at 0, -3, and it has moved down 3. Is this sounding familiar to anyone? Oh, everyone. Excellent. Oh, not you? Okay. What about number 3? Make a prediction before you put it in your calculator. You think it's going to go left 3? Okay, prove it with your calculator. And where does it go? Oh my gosh, our prediction was correct. 1, 2, 3. So what about number 4? Right 3? So that would be 3, 0, right? Okay. Now, in the past, we've always known where to look because we always looked inside or outside of the parentheses, right? When we dealt with quadratic functions, we looked inside or outside the parentheses. When we dealt with absolute value functions, we looked inside or outside of the absolute values. Is there still an inside and outside here? Of what? The square root sign. Okay? Can you clearly tell that this is outside the square root sign? Can you clearly tell this is inside the square root sign? Because of that, you need to make sure when you write things like this that it is clear. Okay? It is clear whether it's inside or outside. So what about number 5? Where do you think this is going to move? Left 4, up 2. Okay, so this crazy kid said last period it should be up 2 and left 4. What did I say? I said, okay. Does the order matter? Does the order ever matter? Oh, yes. Yes, it does. Here's the rule of thumb. If you'll go left to right, you got the order. For the record, this order doesn't matter. If we go up 2 and then left 4, or if we go left 4 and up 2, we're still getting to the same place, aren't we? I'll show you when it will matter. That's a good question. So where's the end point? -4, 2. And we know it went left 4, up 2. Okay? What about 6? We'll get to the order mattering in just a second. Fair enough? Okay, what about number 6? right 2, down 1. So right 2, down 1. So that point is 2, 1. Yes? Oh, excuse me. Thank you very much. 2, negative 1. So what about 7? So where's the number, inside or outside? It's outside. We're dealing with a vertical thing. Vertical, stretch by a factor of 2.5. How did you know it was a stretch and not a compression? It's greater than 1, right? That's perfect. So where's the end point, first of all? 0, 0. But it goes more like this, right? It's stretched. What about 8? And here's how I know that you know for sure what the vocabulary is, because on these there's really no way around it, is there? We got to write it all out, don't we? How did you know it was a compression? Oh, between 0 and 1, right? Not just less than 1, but between 0 and 1. Where's the end point? 0, 0. And what does it look like? It's flatter, like that, maybe? Ish. If you want the exact graph, you know what you can do, right? Put in your calculator. If you want exact points, look at your table, things like that. Or you could put the values in for x and get the values out for y. Okay? All right, what about 9? Reflect over x-axis. Where's the end point? Oh, still at 0, 0? But like that, right? Number 10 matters. Why does number 10 matter? I mean, it starts to matter, is what I should really say. It starts to matter. Say it. We want to say it reflects and then it stretches, right? Reflect. Like I said, it starts to matter, because in this one, I guess it really doesn't, okay? But this is the kind of situation where it's going to start to matter, okay? We're going to start seeing that it matters. Reflects over the x-axis, vertical stretch by a factor of 2. Where's the end point? Okay, so this is what it would look like if I reflected it, right? But this is what it would look like if I stretched it by a factor of 2. So I kind of did it in steps. Here's the reflection, there's the stretch. And points at 0, 0, right? Okay. So let's summarize this. If we are multiplying on the outside, then what? If a is greater than 1, we have a vertical stretch. If a is between 0 and 1, I have a vertical. Sorry, I didn't mean to tell you part of the answer. And if a is less than 0, very good. Reflects over the x-axis. So which one are you going to do next, top or bottom? Top, okay, adding on the outside. If we're adding on the outside, adding k translates the graph up, subtracting k, adding k down the graph Blank? Oh, translates the graph down. Oh, this crazy kid earlier, you know what they put right here? Shifts. I said, okay, don't forget your F. Right? Okay. What about H? Adding on the inside. Adding, yeah, guys, that the arrow's pointing to it. You see that? Okay. Adding H translates the graph left. Subtracting H translates or shifts the graph right. Okay? So go back really quickly over to number 10. Let's pretend that after it said negative 2 times the square root of x, it had a plus 5. How would that change the answer of how does a parent function compare to its, how does a function compare to its parent? Would it still have to be reflex, then stretch, and then move it up 5? If I moved it up 5 and then reflected it, is that what I meant? No. I need to reflect it and then stretch it and then move it up 5, because then it would be right up here, right? Okay? But if I moved it up 5 and then reflected it over the x-axis, that would put it down here at negative 5, wouldn't it? Okay? That's what I was saying earlier, that order mattered. Fair enough? Okay? All right, so go back to number 11, A and B. We'll do these really quickly. And for the record, your homework is the back. 1 through 6 on the back. Okay? Again, these are not difficult. I'm just talking you through them just to get that reminder in your head. Okay? Write the function rules for these graphs. Check them using a graphing calculator. Take the function, f of x equals the square root of x, reflect it over the x-axis, and then translate it up 5. So what is that function rule going to look like? Why didn't you say y equals? Why'd you say f of x equals? Oh, it's asking for specifically for a function rule, isn't it? Okay. F of x equals a negative, and where did that come from? The reflection, good. And then square root of x. Oh, outside plus 5? So I have to be very clear that it's outside to put plus 5. Now, do I need that much space? No. But you have to make sure it's clear that you want it to be outside. Fair enough? Okay, so what about B? F of x. Well, would it be okay if I put y equals? Are these functions? Yes? Okay. I can totally understand how you would automatically gravitate to the f of x, and I get that. It's okay. Alright? So what's going to cause it to stretch? Twice as tall, so it's going to be 2 square root of x plus 3 on the inside. Are you sure? Oh, good. Be sure. So just extend that to make sure you know for sure that it's on the inside. Okay? Any questions about this? Okay? Like I said, 1 through 6 is your homework. Make sure you get that done before you get to class tomorrow. Ask me questions as you go if you have any. Otherwise, peace.